Nature of exothermic and endothermic reactions in terms of breaking and forming of chemical bonds. By looking at the videos, you can see that in order to start a reaction, energy is needed to break the bonds, the covalent bonds. After that, new bonds are formed, okay? And bear in mind, please underline this sentence. Breaking of bonds is an endothermic process. Breaking of bonds is an endothermic process because energy is needed to overcome the covalent bond or the ionic bond. On the contrary, forming of bonds is an exothermic process. Forming of bonds is an exothermic process. That means energy is released. Let's use this as an example. This is a part7 test. Okay, hydrogen react with oxygen to form water. Let's look at this diagram. This is hydrogen bond, HH bond. We have 2 moles of it, HH bond. And then oxygen-oxygen bond, which is a double bond. Oxygen-oxygen double bond. These are strong covalent bonds. In order to start the reaction, energy is needed to break all these strong covalent bonds. After breaking, all these becomes atoms, oxygen atom and hydrogen atoms. Okay? Next, new bonds are formed. Here we have 1 OH, 2 OH, 3 OH, and 4 OH bonds. 4 OH bonds are formed, and in the bond forming, energy is released because it is an exothermic process. In this situation, energy released during bond forming is larger than the energy required for bond breaking. There is a net change in enthalpy, okay? And the value of delta H will have a negative sign. Therefore, it is an exothermic reaction. In other words, for exothermic reaction, energy released during bond forming is larger than the energy needed in bond breaking. Turn to the next page. Let's use another example. Here we have ammonia. Ammonia is decomposed to nitrogen gas and hydrogen gas. Again, let's use the diagram to help you to understand. In ammonia, we have 1, 2, 3, 2 moles of it, 4, 5, 6, 6 NH bond. Energy is needed to break these 6 NH bond. Because energy is needed, therefore it is an endothermic process. After breaking, all becomes atoms. Next, new bonds are formed. We have a new N, triple bond N, and 3 moles of H covalent bond, HH single covalent bond. In this situation, energy needed in bond breaking is larger than the energy released in bond forming. The net change, which is the delta H, has a positive sign. In other words, the reaction is endothermic. Understand? Now, endothermic, pointing upwards. Exothermic, pointing downwards. Let's look at the key points on the next page. Enthalpy change, therefore, is equal to the energy change in bond breaking processes minus energy change in bond-forming processes. Let's look at this table as a summary. For exothermic reaction, energy released in bond breaking is smaller than the energy required in bond forming. Or maybe let's use this enthalpy level diagram. It is very helpful. For exothermic reaction, you remember the enthalpy of reactants should be higher than the enthalpy of products. So, energy needed in bond breaking, represented by this range, is smaller than the energy released in bond forming, which is represented by this range. Finally, we have a negative delta H. On the contrary, for endothermic reaction, here we have bond breaking. Energy needed for bond breaking is larger than the energy released during bond forming. Again, this enthalpy level diagram is very useful. Label the y-axis, which is enthalpy, the reactants, and the products. The enthalpy of the product is larger than the enthalpy of the reactant, so that we have a positive delta H. Energy needed in bond breaking is larger than the energy released in bond forming. Finally, for exothermic reaction, heat is given out to the surroundings, and the delta H will have negative sign. For endothermic reaction, delta H is positive, we have positive sign, and heat is taken in from the surroundings. Understand? Now, let's turn to the next page. Try class practice 33.4. Identify the following as exothermic or endothermic reaction. Explain your answer. First of all, let's use condensation of steam. What is the meaning of condensation? Do you know? Condensation, that means changing of state from gas condensed to liquid. Okay? Now, actually, you may consider how to change liquid to gas. Energy is needed, is that right? Therefore, it is the reverse process, the opposite process. Therefore, it is an exothermic reaction. Do you understand? Exothermic process. Sometimes you can consider the reverse first. Liquid change to gas. Energy is absorbed. Therefore, the reverse of it, that means condensation from steam to liquid, it is an exothermic process. Next, melting of gold is easy. Energy is needed to break the metallic bond. Therefore, it is an endothermic process. Dissociation of chlorine molecule. Here we have a chlorine-chlorine covalent bond. After the reaction, we have two chlorine atoms. Energy is needed to break the covalent bond between Cl-Cl atoms. Therefore, this process must be endothermic. Do you understand? Next, ionization of a sodium atom. We have a sodium atom with electronic configuration 281. And then one electron is removed. Obviously, it is an endothermic process. Understand? Because energy is needed to overcome the electrostatic attraction between the nucleus sodium, we have a nucleus, do you remember? Which is positively charged. There is an attraction between the sodium nucleus and the outermost electron. Energy is needed to overcome the electrostatic attraction between the outermost electron and the positively charged sodium nucleus. Because energy is needed, therefore this process is an endothermic process.